Now, today our topic is what is a digital NOT gate, how it can be realized using a transistor. Okay, so please subscribe my channel. It is a request. Okay, let's coming to the point that what about the NOT gate? You know, NOT gate is the symbol of the NOT gate is this one. This is the symbol. Okay, it is having a triangle and then a bubble. Okay, and there is a single input and single output, one input and only one output. The logic is if A is if A is not true, then this is Q, Q is the output. If A is the input. If A is not true, then Q is true. And if A is true, then Q is not true. It inverts its input signal. Whatever the input signal is, it is inverted by the NOT gate. A NOT gate performs logical negation. NOT gate performs logical negation on its the input that it inverts. In other words, if the input is true, then output will be false. Similarly, a false input results a true output. So that means in terms of bits, if 0 bit, 1 output, if 1 bit, 0 output. Okay. So this is, the logic of the NOT gate. Now let's coming here. This is again our NOT gate, single input and single output. And if input is 0, then this is called the truth table, right? And truth table, it tells us about the relation between the output state and the input state. If the input is 1, output is 0. If input is 0, output is 1. Okay. Now, this we can realize the NOT gate. What it is. So this is a line of high voltage. This is a line of the low voltage. Between the high line and the low line, there are the two further lines. Okay, along this line or in this line, there is a manual switch, and there is a manual switch, can be made on or off. You can push pull switch, and then in the second line there is a relay, and the relay is actually from here to here. This is the circuit of the relay. Then there is a lamp. So this is the circuit through which we can understand the input and output state of the NOT gate. How? Look. Okay. And NOT gate can also be, the truth table can be like, if it is false, it is true. If it is true, then it is false. Right? Now then input A is now, this is input A is false. False mean this switch is open. The switch is open mean false. Then this is true. The lamp giving light, so that means the output state is true. Now next, let's wait. Now what it is here, now this is closed. If the switch is closed, you know, look here, the lamp is off. So if it is closed, mean it is true. The lamp is off, mean it is false. Let's try to understand how it happens. How it happens. When the switch is open, no current is flowing through this line. Okay, then this is when no current is flowing through this line because this switch is open. Now what happened? This is a relay, and normally this switch is closed. Normally closed switch. When the switch remains closed normally, so what happened? The current will flow through this line, and because the current is flowing, so bulb will give us the light. That means output is true, right? Now then, when now when this is closed, current this is closed mean this is true state. Current starts flowing. Now this is a coil, relay coil, and across the relay coil, magnetic energy energize. Energize mean magnetic energy builds up, and that magnetic energy opens this relay switch. This magnetic energy force to open this switch. When this switch becomes open, no current can flow through this line, and now the state of the bulb becomes false because the lamp is not giving us the light now. Okay, so again open mean this is open mean false, this is true. So this is animation which tells us about the working of the NOT gate, right? True false, the relation between input state and the output state. Now here you notice about that when input is zero, okay, output is 1. Okay, input is 0, output is 1. So when the input is 0, the output is 1. So 0 input, output is 1, this state. So if it is 0, this is 1. Now looking here, if here it is a white path means this switch is off. When the switch is off mean false state. The lamp giving light mean this is true. Now when this is true mean a blue line mean this is true, mean high level, mean on, mean 1, a bit 1. This is white line mean no current is passing through lamp. The lamp is not giving light mean the false, mean the 0. So this is 0, that is 1. When it is 1, that is 0. Now, what is the working of the NOT gate through a transistor? This is, NPN transistor. This is NPN transistor. Emitter is grounded, and to the base, a resistor is connected, and this is a VCC supply, and this is a collector resistor, and output is taken at here. Okay, this is output. VCC supply is given. Now, when initially our switch is in the off state, switch is in off state means no voltage is applied at here. No power supplied to the base of the transistor. And as the base there is a zero current. If base is zero current, collector current will be zero. Okay, then we have small, because there is no collector current, but there will be small reverse saturation current, which is called ICO, and which makes the collector more positive. This is, N, P, N. When N is at positive, means reverse biasing. Already the VCC supply is making it reverse biased. And the reverse saturation current also makes the collector more positive as compared to the base, right? As compared to the base. Thus base collector junction is reverse biased. Now as the emitter is grounded, okay, as the emitter is grounded, or it is at 0 volt, and there is a flow of non-zero reverse current, but small reverse current is flowing. Okay, small reverse current flowing through the emitter to compensate the diffusion current, and equal and opposite current flow in the base emitter junction minus ICO. This negative value of the current makes base emitter junction also reverse biased. Okay, the leakage current make it also reverse biased. So as a result, both the junction, collector base junction as well as base emitter junction, both are at reverse biased. So there is no flow of current from collector to emitter or emitter to collector. There is no flow of current. Okay, and this switch act as open switch, and the transistor is said to be in the cutoff state because both junction are at reverse biased. So transistor is in cutoff state, or simply you can say because supply is here, there is no forward biasing, no current is flowing. So that means this point, no current is flowing through the resistance and through the transistor. That means this point will be at the high potential. So whatever this potential is, that will be here. The same potential will be here. So this will be at high potential. Okay. Now, when we give 1 here, okay, when we give 1 here, mean when we give supply here, supply mean this is N, this is P. When we give positive potential at here, then what happen? Base emitter junction becomes forward bias. Okay, current starts flowing. There will be now emitter current, there will be base current as well as the collector current. Now what happened? There will be, because the collector current is flowing, there will be a voltage drop at here. Mean, this is NPN. there will be voltage drop at here. Now this point will come at this point will come at this node will come at low potential because the current is flowing. Okay. Now what happens when this point comes at the low potential? This is N. When N comes at low potential, that means collector base junction also becomes forward bias. Already emitter base is forward bias. Collector base also becomes the forward biased. So when both the junctions are forward biased, the transistor goes to the saturation state. When the state of the transistor is now termed as the saturation state, then there will be smooth flow of current from collector to emitter or emitter to collector, and the transistor act as the closed switch. Or simply you can say when the high voltage is given at here, all the current starts flowing. The current flows through the resistor. Now when the current flows through the resistor, this node comes at the low potential. This is low potential. When this is high, this will be low. Hence the explanation of the NOT gate. If this is high, this will be low. If this is low, this will be high. Okay, thank you.